welcome.
Thank you. Good to be here.
Yeah, we're going to be talking about Pyth today, which is a high-frequency oracle, and we very much intend to do price discovery. So let's get started. For those of you who are not familiar with Pyth and with sort of the oracle spaces here, give me a quick rundown of sort of how you initially got involved in this space and then where the origins of Pyth came from.
Sure. So I have a background in traditional finance. Out of college, I started working at Morgan Stanley on the FX desk at a pivotal time where the FX industry was becoming more electronic, and I had this thesis that it was going to not be banks that were going to win the electronification, especially on the market-making side, but it was going to be specialized systematic trading firms. And so I started a career path going towards trading firms. My first one was at KCG, which was Knight Capital and Gecko that merged together, and they were the largest equity market maker. I was hired to build out the FX business there. And then I ended up at Jump in 2019 when Jump was really getting into the crypto business. In 2017, I got bit with the crypto bug or red-pilled. And what the excitement for me really came out was around what was possible on DeFi and how it could unlock new types of applications on the internet. Most people get into it for one of those types of reasons, and that was it for me. Using a DEX for the very first time, I saw the possibilities. Now, in 2020 and 2021, we had this explosion of the DeFi summer and really DeFi 1.0. And that could be characterized by very low leverage or no fully collateralized lending protocols, AMMs that were almost comically easy to arbitrage, and so much so where you had an interesting branding of the adverse selection in this term impermanent loss. And that was kind of the first wave. And at the time, the oracles for that wave were really predicated on solving for trust, but with no specialization on speed. And it worked there because you had this set of 16-bit applications that really didn't need speed. It was really only when Solana came to the market where kind of high throughput or DeFi 2.0 seemed like it was possible. And it was then where we realized, or I realized, that high-speed oracles were going to be a choke point or a bottleneck to the expansion of the growth.
Yeah, maybe we even step back a second and sort of one of the core problems that oracles are trying to solve is that the blockchain programs only know what's on the blockchain, right? This is kind of why all of the classic systems in DeFi 1.0, they're swaps, they're AMMs, they're things that fundamentally don't really need external data in theory in a perfect vacuum to be able to do what they're doing. You don't really need to know anything outside of a network to buy an NFT, to swap tokens for something along those lines, until you want to try and make sure that markets are efficient, right? Because otherwise you have a massive price divergence between one information bubble and the entire rest of the world around it. So at the same time though, these oracle networks have historically been pretty slow. To be fair, blockchain is still very slow compared to traditional finance, but the oracle networks that exist previous to Pyth have been quite slow, and they've had a lot of limitations from a design perspective. So you talked a little bit about this idea of DeFi 2.0 and that we needed faster oracles. What was actually some of the market reason that we needed faster oracles besides it would just be nice to have more data?
Yeah. So DeFi 2.0 ushered in things that we hadn't seen possible on DeFi 1.0, which would be on-chain order books, on-chain perpetual markets, things like that. At a 15-second or greater block speed, you can't do any of those things. And you can kind of think about that in terms of the execution quality that you'd have. If you're trading something on a centralized exchange that's ticking multiple times per second, and then you have something with a resolution of only every 15 seconds, the likelihood that you're going to have big volatility spikes in that 15 seconds means that somebody is going to be getting a trade that's going to lose money. And the way that you compensate for it is you basically put these giant spreads in place. And so that's why it was functionally never possible before. So what you needed high-speed oracles for is to be able to power these applications and allow them to be efficient relative to the rest of the markets, right? There's always going to be a time where the markets exist on centralized exchanges and on decentralized exchanges, and there's a couple of strategies that you can have to tie those things together. One strategy is you just have high-frequency trading firms on all the exchanges, and they're incentivized to run arbitrage trades to smooth out the risk and make those prices converge. But that requires onboarding all the big systematic trading firms to all these DEXs. Of course, there's going to be some cold start problem, so it's not great for bootstrapping. Oracles are great for bootstrapping because it allows you to bring in a universal price that accounts for both the prices on decentralized exchanges and centralized exchanges and publish it on chain. And then there's a couple of strategies that you can have to tie together those markets. One thing that's very simple is you can have the Oracle price be the execution price. And so if you can use an example where you have a high-fidelity Bitcoin price that's updating every 400 milliseconds, you can have market makers that are effectively pegged to this, or liquidity pool, that are taking the other sides of trades and let people cross the spread at that price. And it'll be a very fair price, right? There won't be this adverse selection, there won't be this impermanent loss, and certainly not to the degrees that we saw in kind of DeFi 1.0. There are other variations of this as the liquidity starts to build on chain, because you'll have uniqueness of orders in a kind of expressive order book. And then you can take the Oracle price and you can use it to nudge any differences back into line. So if you have a perpetual market that's on chain and it's trading at a significant discount to like the universal price, you can create a funding rate where if it's trading at a discount, then the shorts pay the longs, and it sort of nudges it back into line. So those are some of the things that were initially needed.
Yeah, it's funny to kind of hear you talk about what all the specifics of what an oracle needs to do, because I think one thing that is surprising to folks who maybe they started off in crypto and blockchain, or they started off in more sort of traditional Web 2 companies, and they found their way into something that starts touching this high-frequency trading world, or just financial technology in general, is how poorly built most, you can call them San Francisco software stacks, are for the needs of what a trading firm has, or what folks who want to do this sort of, call it professionalized trading style operations on a blockchain need. And like the work that we do at something like the Solana Foundation is all on optimizing that base layer of the Solana virtual machine to be as fast as possible and be able to be as performant with as fast finality. But even once you've done that, there's a whole bunch of specific logic and sort of almost like a programming paradigm that you have to bring to an oracle to make it actually useful. And that was one of the things that we heard from DeFi traders, who was like, oh, Pyth lets us do things that other oracles just simply don't let us do.
Yeah. And I think that was the assumption going into the first generation of oracles. It's a very similar assumption that I think, as you said, like the San Francisco Silicon Valley approach to problems has been, it's let's overgeneralize, and data is data is data, and we need to get data onto the blockchains because you have to update the state so that it can be usable. Someone has to update the state. What we really need to solve for is trust. That's the primary thing. Like the first generation of oracles were solving for trust. And the way they did that was they said, all right, we'll slow everything down, because the slower you go, the more trustworthy, the less likelihood that the price is going to be incorrect. And so first oracle networks were basically networks of nodes that were instructed to go scrape prices from websites that were aggregating them on the internet. Those websites were generally aggregating this information about 60 seconds old. They would update every 30 seconds or so, and then the nodes in the network would aggregate it again together, and it would get published sometime around 3 minutes latent. Yeah. And if you're just generalizing and you want to bring in sports scores or weather, that 3-minute period doesn't seem meaningful. In fact, they would actually update directly onto blockchains at these predetermined schedules. They'd push from 1 hour or 50 basis points move. And again, if you're overgeneralizing the problem, that seems totally reasonable. And it's probably one of the reasons why Google organizes the world's information, but yet all of the world's financial data goes through something like Bloomberg that's usable.
Yeah.
It is such a specialized industry for financial data, and it deserves to have a specialized solution. So Pyth was designed to be the specialized solution for financial market data that cuts out all of that latency and publishes it in a way that's very usable for DeFi protocols.
Yeah, I mean, the analogy I've used for this sort of thing is like, I roughly need to know if it's going to rain today, and a farmer needs to know exactly how many inches over what duration of time to actually make use of that data to harvest crops or grow crops. And it's just a very different type of application for that. But one of the things, so you guys just put out the white paper for Pyth 2.0, let's call it, right?
Yeah.
It's the full vision of how you take something that today is run by a smaller group of publishers and expand that out. I want to talk about that future, but also, today Pyth has done something that I'm not sure anyone else besides a lobbying group has managed to do, which is bring together a bunch of traditional financial firms that usually don't collaborate to collaborate on something. How did that actually come about, and why are these competitors actually collaborating on a network like Pyth?
Yeah, you're totally right. There are today 90 institutions, like household name institutions, that are publishing directly to Pyth, and most people...
Maybe your household.
Yeah, maybe our household. So most trading firms, Jane Street, Susquehanna, Jump Trading, Hudson River, Optiver, Flow Traders, the list goes on. Most of the large crypto exchanges, from Binance on down to the smaller ones, U.S. equity exchanges, starting with Cboe Global Markets, who's actually the third largest with its BATS market, as well as obviously options. So it's all these institutions, and when people think about like the institutionalization of crypto, it's oftentimes not realized that there are actually these 90 institutions who are submitting data all day, every day, to Pyth. And that's amazing. And the reason why that's possible is because of blockchains. And that was the first proof point in developing Pyth. Similar to like a DePIN network, you need to make the product universally usable before you can go and acquire any kind of clients. A Hive Mapper network that's really good in Boston is not going to be used by very many people. It needs to be quite complete. And the same thing goes for market data. We wanted to make sure that we covered a strong enough caliber of categories, from crypto to US equities, FX, metals, interest rates, that would be convincing to trust this data on chain. And so the innovations of blockchains allows you to do that, right? And I'll give you some examples. Blockchains would, even just taking like a Bitcoin miner, if all of the Bitcoin miners had to first join some sort of an LLC or sign up to an employment agreement in order to earn Bitcoin rewards, it never, ever would have worked. The Solana validators, they probably don't all know each other. Some of them probably hate each other. They're probably not selected or even have relationships with the Solana Foundation. And that's the same with Pyth, right? We don't have strong bonds or camaraderie around the publishers. We just have incentives, true incentives, for them to want to participate in this network. And we expect that to be something that can be self-sustainable and live on and be autonomous.
So I want to push you a little on that, because you've described why these publishers would want Pyth to exist, but not necessarily why they would want to do it themselves, right? This sounds on its face like a classic governing the commons problem, right? It would be great if all this data were on chain. Boy, I hope someone does it. So what is the part that actually has brought them to say, yes, I'm going to invest software engineering resources, I'm going to spin this up, I'm going to deal with the messiness of data on blockchain, I'm going to learn something new that maybe today doesn't actually make me any more money?
Yeah. So this is the instructive part of having a white paper. So a protocol needs a white paper to basically craft out the vision of what is being built in its earliest days while some of the kind of application and tooling gets developed. And so that white paper is what a lot of these trading firms have first read, and they understood what the vision was. And the vision was that they would be rewarded for their quality of data. And that was something that was strong enough to bring trading firms in because it allowed them to enter into the lucrative business of publishing market data, financial market data. Some people may know this, but not everyone will. Financial market data in 2022 was a $6.5 billion business, and most of those revenues went to large exchanges. So trading firms have been looking for an opportunity to be able to monetize their market data for some period of time, and seeing that Pyth was a solution that allowed them to do that, that was very, very exciting. Now, on the flip side, from an exchange perspective, no one monetizes their market data better than exchanges, and so a network like Pyth allows them to have potentially a new green fields of distribution. So that's what excites them.
Yeah.
And so we've basically gotten to this point where we've issued this version 2 of the white paper today. Version 1 talked about what could this network look like, how could it monetize, and how could it basically live on and start to decentralize and be owned by the network of users. And what Pyth White Paper V2 does is it talks about the state as it is today. So Pyth is actually quite mature in its life cycle. There's 90 publishers, there's lots of users, and it is in a position where it can start to turn over some of those functions to be in the hands of the community and the users to make the decisions on how it's going to be governed going forward. And that's really what you'll see. It's actually going to be a lighter version of the white paper because some of these more speculative parts have been resolved, it's been simplified, and it really brings the network up to where it is today. And then in the future, it will be decided by the token holders, and there won't be needs for white papers.
Yeah, it's really, one of the big updates in this white paper is talking about the governance model and how things like a new data feed could be proposed by publishers and consumers to be added in. But today the data feeds are not just the price of Bitcoin, the price of Sol, the price of these sorts of things. It includes things like the price of equities, and I think there's some commodities on there too. Yeah. What is sort of the hope that people either will build or are building today when we take data that really, everything else we're talking about in the traditional Oracle model, it's referential to blockchain. I want to know the price Bitcoin is trading on Coinbase or in another exchange so I can make sure I price it correctly in my decentralized finance application. But we don't live in a world yet where there's tokenized Apple stock or Tesla stock, and there really isn't much tokenized gold or something like that. So what's kind of the suite of products that folks will actually be consuming that data with?
There's 360 symbols today. 25% of them are non-crypto assets, which means the rest of them are crypto assets. And they're available on 32 different blockchains. There's 210 applications that are using them. Most of the demand today is in crypto. So then why are we publishing 25% that are non-crypto? Well, first off, there's some demand that's there. But the other thing is to show what's possible. Because the thing that excited me about DeFi was it could potentially create or it will create, I believe, it will create a way for capital markets to be distributed places where they've never been distributed before. So farmers in Argentina would love to get access to T-bills, right? It's way better than having access to any Argentinian peso-based investment. And imagine if they were to be able to invest in the S&P 500 as well. It's tricky, and there are areas in the world where it is tricky. And I think like an instructive analogy to think about for how that can play out is, especially sitting here in the US, where it's difficult to conjure how limited some parts of the world are in terms of their access to retirement plans and things. There was a period in time where, like in the 1980s, the US had great landlines, and it worked really well. Like you could call anyone, everyone had a phone in their house. In the Nordics, where it's the lowest population density in some of the world and some of the roughest terrain, it just wasn't possible. Like that would never have worked. And so they had to innovate, and Nokia and Ericsson were some of the first to create like really sustainable business models around the mobile phone network. Over time, of course, that was better than the landlines, and that technology was shipped here. I think the same thing will happen over time. And so there's some end state where there's a harmonization of what we would call real-world assets or like equities that gets traded on a blockchain for the accessibility for the rest of the world. And in order to have that function, at a very minimum, to bootstrap it, you'll need an Oracle price in the way that I described before. But even over a long period of time, it's probably likely that it'll be an instructive part of the workflow of those applications.
Yeah, I mean, that is one of the biggest promises of blockchain in general. And we see this today, but the ability to unlock markets that are, from whatever reason, not able to access something. I mean, one of the crazy stats is even if you bought Bitcoin at the peak in Turkey or Venezuela, you are still massively up compared to the local currency because of just how much that local currency has deflated, or inflated, which is really interesting to see that there are a lot of these applications where maybe we're sitting in a, pretty economically and politically stable country, even though it doesn't always feel like that, compared to the rest of the world, but this is still a privilege, and that there's a lot of applications for crypto that make a ton of sense in economies or political situations that are a little less stable. And this is kind of one of those pieces of infrastructure that helps us get there. I want to go to one piece of what you talked about, though, which is that there's 30 blockchains right now that Pyth publishes price feeds on. And publish, we should get into the definition of publish, too, because the way that the actual Oracle mechanism works here is different than what most Oracles work on. But before joining Solana and the Solana ecosystem, I worked at Bison Trails, and we ran blockchain infrastructure for over 30 protocols. And it was a pretty gargantuan effort to actually keep node infrastructure up for all of that. So I want to talk about the way the Oracle works, but then also how you are able to support 30 plus different blockchains today.
Yeah. So I think I've told you a little bit about proof point number one in building the Pyth network was, can we create a supply that's going to be meaningful? And the 90 publishers has been instructive in doing so. Just to give you a sense of what the slope of that curve has looked like, it's been about 3 publishers per month since inception and continues to be about that rate. Today we have 3 new publishers that join every single month. Pyth started its life on Solana mainnet. And the idea was to publish in a public layer 1 blockchain so that you can provably show the provenance of every one of these matches. People are going to really want to trust and verify that Pyth is doing exactly what it says it's doing, so using Solana Block Explorer allowed it to do that. And the first use cases were the ones on Solana, and within 6 months, the market share that Pyth had accomplished for protocols that use an Oracle on Solana was over 90%, and it's been that way ever since. But there was a time when Pyth was going cross-chain, we started to realize some of the benefits of not being on a general purpose layer 1 blockchain. And so we've actually created PythNet as a SVM, Solana Virtual Machine. And this has allowed us to really scale up the network. So when we were on Solana mainnet, there was under 100 symbols. We had about 50 publishers at the time. As I mentioned before, it's 360 symbols today, and we grow about 10 to 25 per month with 90 different publishers. So it's a pretty chatty application. There's about 300 million transactions per day on the PythNet instance. And so it's connected to Wormhole. And Wormhole acts as a distribution mechanism for Pyth.
And just Wormhole, for those who aren't familiar, decentralized bridge that connects multiple blockchains, makes it easy to move data from one place to another.
Thank you. But this creates the possibility for a new architecture of the economic delivery of Oracle prices. So it ends up looking like a hub and spoke. Everything gets pushed onto PythNet at these 400 millisecond block times. But then all of the downstream chains, by virtue of being connected through this bridging technology of Wormhole, means that they can be pulled on chain. And users, say on Optimism, can watch the Pyth price updating on PythNet in real time and then choose to have a price delivered onto Optimism that would allow them to, say, trade on a smart contract like Synthetics. And that's cool because that gives a very simplified economic model where each one of those deliveries can come with a price fee that can eventually get distributed back to the publishers of the network. This is all new. This is not how the first generation of oracles worked. The first generation of oracles, as I mentioned, would push to each chain independently, which created a wide variety of what was available on each chain. So if you look at a first generation oracle on Ethereum, they may have 200 symbols available that update every hour, And if you look at what their offering is on, say, Solana, it could be a small fraction of that. So having a unified view gives us tremendous amount of scalability, especially since it's one where the validators of the Pyth net are the publishers themselves, and we've effectively increased the ability to scale this to kind of n number of symbols.
Yeah, you can sort of think about this as the transition from like linear and broadcast television to streaming, right? Like if you want to support 60 channels of live television, you need 60 channels publishing data constantly. Or you can have a giant library of Netflix and just grab what you need as you need it.
It's a great analogy.
Yeah, and I think that there's one piece there that's also key, which is like a lot of, you might say, well, why can't my application just look at the price on PythNet and call it a day? But this process of actually importing a price into a blockchain, it comes with all the assurances that would natively be on PythNet as well. And so that's kind of one of the interesting pieces you guys have done there is you've set up an economic incentive where as people consume data, everyone else on the chain then becomes able to benefit from that price being imported. So if I'm building an application that doesn't need high frequency data, right, I can maybe look, oh, the last time someone imported a Pyth price was a minute ago. That's good enough for me. I don't need to pay the gas fee to bring this price in.
Yep, that's correct. And as you mentioned, the importance of it being delivered into a smart contract gives the user of that, that smart contract the assurances that it's signed, it has all the benefits of, being trustworthy and coming from the sources that.
Yeah. So how do you manage the process of folks actually paying for this data? If you're supporting 30 blockchains, there's a lot of different tokens out there. There's a lot of different fee structures involved. Like, how does the network both manage pricing and actually then protocol revenue, for lack of a better term, at that stage?
Yeah, so this is something that will get determined by the community as things get decentralized. Today, Pyth charges a fee, but that fee is very small. It's effectively like a placeholder. Mm-hmm. It's paid in the native gas token of the target chain. That's one of the nuances of kind of managing all of these different downstream contracts. As a comparison, a year ago, Pyth was on Solana and Solana only. So adding 32 blockchains in a period of about 9 months is a lot of work. And there are nuances and things that get discovered along the way. But by doing so in a kind of a scalable way, as I described, and leveraging bridging technology, which has really enabled this to happen, Pyth would not have been able to fork Solana and run PythNet as an SVM that's meaningful if it wasn't for good bridging technology, because we're an island and we don't have any other applications that would use it. So those are kind of the tools that have matured, and to kind of take this back into the initial why did we build Pyth and what is it trying to serve. It's really trying to bring infrastructure that can enable new applications, and we think that Pyth does this. We've seen the growth of on-chain perpetual markets to somewhere about 2% of the volume of Binance in about a year, and a year ago it was about 0. That's novel and new, and that's enabled by high-speed oracles. It's also enabled by bridging, and what we're excited is that the infrastructure does need to be built and upgraded first before you can have the applications, and we are seeing that get done today.
Yeah, I mean, one of the really cool thing is that PythNet is still running on the Solana virtual machine. And so there's this really nice interplay between technology updates that the Solana Foundation and other folks building on the core SVM client and Solana create that then get used in Pyth. Like the Merkle tree system we built for compression is now how Pyth publishes price feeds. There's stuff that like you guys have battle tested just because of the volume of transactions and coordination that then ends up making the main network better, let alone the work that's being done on FireDancer, which is the new client that's anywhere between 2 to 100x faster depending on how you benchmark it. So it's really exciting to see all that stuff coming and PythNet actually coming out and using that. As you move forward and look at like that validator network on PythNet, do you anticipate this staying as kind of a semi-proof of authority network where all the data publishers are running nodes and those are known? Or over time, like how does that decentralization work out?
So I get to make this kind of cool or annoying disclaimer when I say this, which it almost doesn't really matter what I think, because at some point the community will decide what's going to happen. I like the proof of authority model that Pyth uses, because each of the publishers today is disclosed, and they are a Mike Cahill household name, and so they wouldn't want to shame themselves in my household. But at some point, it may change and it may evolve, but that's difficult to predict. I would just kind of reiterate what you said, which is by having PythNet be supported by the SVM, it's incredibly important. So Pyth is not designed to go off and be its own island, doesn't want to be a layer one. It just wants to be able to scale as much as it possibly can and benefit from all the continued updates. We're probably more excited than anyone else for, say, like the Fire Dancer deployment, because that means that we can increase our throughput as well. So it is nice to see how the ecosystem is starting to evolve, and not all development needs to happen on just the mainnet, but you start to see this kind of network of nation states being developed on a familiar technology.
Yeah. Well, if this conversation got you interested to learn more, we actually have a conversation with your CTO on the Validated podcast, where we go into more of the technical details. But that's all the time we got today. Thanks, Mike.